Alright, so in this lecture, I'm going to be explaining a survey of all event extraction articles till 2022. So this paper in 2022, Event Extraction, a Survey. Extracting the reported events from text is one of key research themes in natural language processing. This process includes several tasks such as event detection, argument extraction, and role labeling. As one of the most important topics in natural language processing and natural language understanding, the applications of event extraction spans across a wide range of domains such as newswire, biomedical domain, history, humanity, cybersecurity. Of course, this one is more challenging. So ACE 25 defines an event schema whose terminologies have been widely used in event extraction. For example, we have different event types such as life, movement, transaction, business, conflict, contact, and each one has its event subtype. For example, event type life has event subtype be born, married, divorce. These are the event subtypes. Earlier documents in the case have included embarrassing details about Perksville. And you see here retirement is just an event which is the trigger event. And this is the architecture for this article in 2015 that just uses CNN. Very simple. Just use CNN. And then, of course, first you should create these entities. For example, begin person. And another article in 2016 is the joint training of event extraction, that we train everything jointly. First, we do sentence encoding. Then we have, of course, with bidirectional neural network, we get trigger prediction and then argument role labeling, role prediction, and memory vectors. Because we also have input sentence, indexes of trigger and entity mention candidates that we give it to local argument feature generator. But what if we have dependency parse information? So we have an added information that we can leverage. So graph-based representation such as syntactic dependency trees has not been explored for event extraction, even though they provide an effect. Of course, there are many articles in this area. Graph convolutional networks, this you know all about it. It's very important. If you have a dependency tree, then you have the transition matrix, adjacency matrix, and then you can create with this adjacency matrix, you can create your graph neural networks. GCN is just one of them. You can use graph attention network, message passing, any other approach. So this is a dependency tree for sentence. For example, this end subject is the relation between two words, relation between this verb and this noun. And the other idea is joint modeling. This idea died, this model in 2019, that you have token representation, you have span enumeration, but you also care about, if you don't care about co-reference, you have problem. You don't have good accuracy. So they are very important. Then you have iterative inference and propagation for relations and entities. But what if we have low resource event extraction? That's why we need zero-shot learning. We need domain adaptation to even enlarge our domain using those pseudo labels that I will explain in a different playlist called domain adaptation. And in zero-shot learning, there are very good articles that I've explained. For example, I've explained this article in this playlist. Or you can use few-shot learning. And for example, one of my favorite approaches for few-shot learning is Protonet. Another approach is using this paper, 2019. So you have a dependency tree so you can create your graph convolution and learn it with what objective? With trigger and argument row, those objectives that you use. Or even you want to do relation extraction, then you have another objective. All of them are useful.